All right. So you're able to write?
Yeah.
Can? Hello?
You cannot see, is it? Like,
I can see. I mean, like, are you able to write?
yeah.
Can. So you click on draw, then you click on the curly line, then you can draw, right?
Mm-hmm.
Okay. You try to use like you try to draw a straight line using the straight line tools. See if you can use that tool. Good. Okay. Great.
Yeah.
Okay, let's carry on. So we know that this is a probability distribution function and the summation of all probabilities will be equals to 1.
Yeah.
Yes? Okay. Then after that, we also learn about this thing called, what is this called?
Expectation.
Yes, this is called expectation. Okay, it's also called what?
EX. I don't know.
EX, okay. It's also called mean. It's also called average. Okay?
Mm-hmm.
Then we also learn this, variance, right? Okay,
Mm-hmm.
this variance. What's the formula for expectation? Can you write it up for me? Nice. What about variance? Very good. Very good. Okay. Then after that, we also learn about the properties of expectation and variance, right?
Mm-hmm.
Okay. So we learned that, let's say, expectation of, expectation of 2x plus 5 will be equals to what? What about variance of 2x plus 5? Good. Okay, then after that, let's move on to binomial.
I couldn't do one statistics question though.
Oh, you mean for the test?
Yeah.
Doesn't matter. We will review it when you get it back because we can't really like go through and rectify any concept right now.
Okay.
Yeah, right? Okay, help me to clear your workings here. Okay, good. Okay, so we move on to binomial. Okay, so for binomial, you must always, step 1, you must always define the random
Fine.
variable, right? Okay, so after you define the random variable, step 2, you have to define the distribution. Okay, so
Mm-hmm.
afterwards, step 3, you define what is the problem. Okay, like let's say x is equals to the number of um, people contracting
Coronavirus.
COVID. Okay, sure. So let's say the distribution x will follow a binomial distribution. Let's say let's say how the probability is distributed is through the means of binomial distribution. So X will follow binomial distribution. Let's say we have 10 people. Okay, probability of contracting, I mean, is pretty low. Let's say it's 0.2. Okay, so the question wants you to find probability out of 10 people. What's the probability that more than 2 people will contract this? So how are we going to find this?
Oh.
Very good, very good. You still remember. Okay, so that is for a binomial question itself when you ask, for the probability. So moving on, right? They will also ask you to find the average number of people that contracts this virus. Okay, so when they ask you what's the expected number of people that will contract this virus, how are you going to find it? Nice. Okay, very good. So what if they ask you to find the variance? Okay, awesome. I think you don't need tuition anymore.
What?
You don't need tuition already. Because this today will be our last lesson. No lah, we still have normal distribution, sampling, hypothesis testing, then correlation. Then you don't need tuition anymore.
The concept's okay, but like
Application,
doing,
right?
yeah.
Yeah. So if the application has problem, right? Okay, it has got nothing to do with the concepts, of course. It has got everything to do with figuring out the setter's intention, breaking down of question. Yeah, because you yourself, you know it. There are certain topics that you have acquired a particular level of mastery. You know that you have really mastered some question setups where you look at the question these you look at the questions from a particular topic and you know how to break it down, right? You know that there's only this number of ways where they can ask, you know what the setter wants from you, but because of all these newer topics, right, you are still unable to decipher, hey, this is how they create the question. These are the different variations of the question setups. You're still not able to identify that yet. But as we do more questions, slowly you will start to register it. Okay?
Yeah.
Don't worry about it.
Yeah.
It's just a process. That's why they always say it's a learning process, right? Yeah. If not, it won't be called a process really. Yeah. It'll be called a learning result. Okay, so this is pretty much binomial. Of course, this is only the technique part. We will be going through more questions. But now I want to move on to normal distribution. I think we are left with just a bit, and then we can wrap up the topic. Then we move on to a bit of questions. Then today maybe we can move on to a bit of sampling. Then after that we'll call it a day.
Okay.
Okay? Great.
Okay.
Okay, how many to erase it? We'll go to normal. In the meanwhile, right, during the lesson, I mean, same thing, you need a break, let me know, but go to toilet, anything. Okay?
What?
If you need a break, you can let me know.
Oh, okay.
Yeah. Okay. So coming back to normal distribution, okay. The difference, hold on. The difference between normal distribution and binomial distribution, okay. Binomial, normal, okay. Binomial distribution measures what kind of values?
The whole numbers. What's
Whole
it called?
numbers, which is also called,
Starts with R. Integer.
yes. How is this start? How is this starting with R?
I don't
So
know.
for normal, yes, for normal it starts with R. For normal it starts with R.
Real numbers.
Yes. Real numbers. Okay. That's why for binomial curves, it goes in blocks. Okay. For normal curve, it's a smooth bell-shaped curve. Okay. But at a microscopic level, you are actually seeing very, very, very small rectangular blocks form.
Okay.
It's just that it's like integration. You learn integration, right? It's
Mm.
every single block is negligible already. They are of very infinite number of rectangles with negligible width. That's why it forms like a smooth curve. Just to capture the highest value of each rectangular block. Okay?
Okay.
Yeah. Anyway, don't worry. This whole session will be recorded. Then if you don't understand, right, you can go to, I'll send you a link. Then you can rewatch it again.
Okay.
Yeah. Anyway, this is going on to YouTube lah, so serious. Yeah. So over here, okay, same thing applies for both binomial and normal. Define random variable, define distribution, define question. Okay. So over here, they did not define the random variable. They did not say what is x. But of course, this is not a real A-levels question. This is just helping you to get through the GC techniques. Okay. So they only define the distribution here. This 2 over here is the what? What is this? What's the 2? What does this 2 signify?
This sigma.
No. This 2 here is the mean, the expectation. What about this 4 here?
Does that refer to the variance?
Yes, 4 is the variance. Okay, but usually, remember, we mentioned before, we do not want to annotate it in terms of variance. We want it to be sigma squared. What is sigma? Sigma is standard deviation, right?
Yeah.
So we want it to be x follows normal distribution. What?
2 square root 4.
2 and 2 square.
Oh, okay.
Right? Correct.
Mm-hmm.
So in this case, this one will be
106 square.
yes. Okay, we have gone through how to find all these things, so I'll not go through again.
Okay.
Okay, remember this one is using what? Inverse norm, right? Inverse norm. Remember?
No?
Don't remember. Okay, then we can try this. Okay, let's try this question. Okay, so you know there's 100 and comma 6 squared, right?
Yeah.
So right now you want to find what is A and what is B. Okay. So over here, when they say the probability of y less or equals to a is equals to 0.8907. Okay. So there's this particular value of a. When you find the probability on the left of a all the way to the left tail, okay, you are going to get 0.8907. That's a huge probability, right?
Yeah.
Yeah. Okay. So usually if we want to find the probability itself, when you want to find probability, okay, when you want to find probability, you'll be using normal CDF. Okay. But when you want to find the limits, okay, like that, the A and B here, you'll be using
Yes.
inverse norm.
Kenny,
Mm.
do you mind like sending me the soft copy so I can write as the class, write with you on my copy?
Actually, that time I printed this for you already.
Oh,
Remember or
wait.
not?
I went get it.
Yeah, yeah.
Okay, got it.
You probably have written something there already.
Yeah.
Yeah. So we went through this before. So when you want to, this is very important to understand this. To find probability, you use normal CDF. To find limits, you use inverse norm. Okay. So inverse norm will tell you which tail. Okay. You have to select a tail. In this case, look at the arrow. It's pointing to the left. This will be left tail. Pointing to the right, it will be right tail. Understand? This is the trick.
Yep.
Can you try?
Then the area would be X, is it?
The area, yes, which is this. Be careful when you key in a sigma.
107.38.
107.3. Yeah, you got it. You got it. Okay. So for part 2,
107.38.
exactly the same.
Then for what's it called? For normal, right?
Hmm.
Do we put do we estimate it to 3SF or
3SF.
no?
Yes, you have
Because
to give up to 5SF first, then give 3SF. You always do that.
Okay.
Mm.
I'm done.
Okay. So previously, we also went through this example. Okay. The steps are still the same. And then define the random variable, define the distribution, then define the question. Okay. So in this case, they did not define the random variable, but in a proper question, you should be defining the random variable. So and they already gave you the distribution itself. Okay. And they also gave you the question. By right, in a proper question, later we will see in a question, they will be explaining the question in English. It's your job to translate it into a mathematical statement.
Okay.
Okay, so the thing about this kind of question is that there's an extra step 4. When you define the after defining the question, step 4 is to find the new variable. Okay, so let's take A for example. You have P, you want to find where X is lesser than Y. How are you going to do that, man? It's not possible. It's not possible to find a probability of this. The only way to do this is to retranslate this into P, X minus Y lesser than 0. So from here, you will have a new random variable. Okay, so you have to go and find what is X minus Y, the new distribution of X minus Y. So you need to put in the expectation of X minus Y here and the variance of X minus Y over here. So that you can calculate this probability. Okay?
Yeah.
Mm.
Yeah. Got it.
Okay, got it. So that is for part A. So let's say for part B. Okay. So for part B it's the same thing. After you define the first three, the last step is to define the new random variable. So in this case, the new random variable will be what? What is the new random variable?
Px plus 3y minus 385.
Okay, you don't have to do that. Because 385 is a constant. You're going to leave the constant where it is. We always want to leave the constant on the right hand side. So our new random variable will be this. X plus 3y. Okay. So after that, we just have to find the expectation for X plus 3y and the variance of X plus 3y. I mean, let's say you can let A to be equals to A plus 3y. So if that's it, you can find expectation of A and variance of A. Once you find that, so you can find the probability of A to be greater than 385 using the GC by formal CDF.
So for this one, do I use which function do I use? Do I use the inverse?
No, you are finding what? Remember just now I mentioned, you're finding not if you're finding probability, you use normal CDF. If you are finding limits, like you're finding this thing over here, you do not know what is this thing, you are using you should be using inverse norm.
Okay.
Okay. Don't worry, if you feel that you miss out anything, you can backtrack later.
Okay.
Can. Okay. So this is the reason why we learn expectation and variance in the earlier chapters of statistics. We learn the properties because from there then we will know how to manipulate them. How do we split them up? So over here we know that it's expectation of x plus 3 expectation of y. From here you know it's variance of x plus what?
9 variance.
Yes. So just from discrete random variable, you see we are applying it onto normal distribution because the expectation, the properties of expectation and variance will remain the same for both distribution. It's just that the kind of variable that they are measuring are different only. Understand, right?
Yeah.
So lastly, for this one, probability of x plus y1 plus y2 plus y3. Okay, so what do you think is the random variable?
What do you think is the
Random variable.
x plus y1 plus y2 plus y3?
Yes. So W will be, we will let W be x plus y1 plus y2 plus y3. Okay, so when you find the expectation of W, it will be expectation of x plus expectation of y1 plus expectation of y2 plus expectation of y3. Okay, so we do know the expectation of x. It is 100. But what's the expectation of y1?
90.
Okay, fair enough. But what's the expectation of y2?
90.
Also 90, which means the expectation of y3 is also 90. But why do they have to denote as y1, y2, y3? Why can't they just say it's y? Okay, because y1, y2, y3, they are independent observations. Understand? They are independent observations from the same product.
Okay.
Okay, it's like, let's say uh the height of girls in your softball team. Okay, they have the height follows normal distribution of, let's say the height is like 160, okay, with variance 5 square. So I can choose any player, okay, I can choose any player from the softball team.
Yeah.
Okay, and the mean height will always be 160. Yeah, that's what this is trying to say. Means I want to find, I will just bring out one individual and the mean height will be 160. That's how I'm going to count it. You understand what I'm trying? Okay, maybe not one. As in, like, let's say you're in your softball team from Sec 1 all the way to Sec 4. You have like 100. You have like 100 softballers, right? For instance. So I'm going to, like, maybe out of this 100, I choose like 10. I choose 10. So when I choose 10 from this whole softball team with mean of 160 cm, the mean of the sample size is also going to be 160 because it's from the same family. Understand?
Not really.
Okay, because okay, let's talk about Coke. Coke amount of sugar in Coke. Okay, the amount of sugar in Coke, let's say, is 160 gram on the shelf. On the shelf.
Yeah.
Okay, on the shelf. They in on the Coca-Cola headquarters say that, oh, it's 160 gram. The mean amount of sugar is 160 grams of all the Coke bottles placed on the shelf. Okay, then right now, right, I'm going to take like 10 bottles off the shelf. Okay, what do you think is the mean amount of sugar in the 10 bottles?
160.
Yeah, no? Understand?
Yeah.
Yeah. So Y1 is like a sample size of 10 bottles. Y2 will be a sample size of another 10 bottles. Y3 is a sample size of another 10 more bottles. That's why I say that they are independent observations. Get it now? Okay, maybe I shouldn't have used height as example just now because, I mean, they are very, very tall softballers and they are very, very short softballers.
Yeah.
Yeah, that's why you were confused. But when I use Coke bottles, it's more homogeneous. Will the amount of sugar differ between the bottles? Yes, they will. But by how much? Not a lot lah.
Yeah.
You know what I mean? If you find a bottle that is like instead of 160 gram become 320 gram, I think that's it for the
Need
fella.
to point it out.
Yeah, but all in all, don't drink Coke ah. Coke is not good, man. Do you know that they use it to wash toilet bowl?
Oh yeah.
Yeah, it's like damn powerful, It really is like it is corrosive somehow.
But it's so good.
I
Like
know.
especially when
It's
you're like damn
super
thirsty.
refreshing. That's the thing.
Yeah.
But Coke or Pepsi?
Pepsi.
But just a moment earlier, you were praising Coke.
But I prefer Pepsi.
Why ah?
I don't know.
You like blue?
I don't know why. It tastes a bit different.
Yeah, definitely lah. Walao eh.
Why?
Okay. Good to know. Next time I'll buy you Pepsi.
Yeah.
Okay. So you understand now, huh? So for expectation is 90 plus 9 plus 90 lah, which is actually also 3 times of the expectation of Y.
Yeah.
Make sense? Okay. So right now, if I want to find the variance, if I want to find the variance of W, it will be
X
variance of X
plus 3 variance Y.
Aha.
Plus
Hold
3.
on.
No, plus 9 variance Y.
Aha. Wait.
Ah.
So we have to really manually write it out. Do not jump to conclusion first. Okay, we have variance of Y1 plus variance of Y2 plus variance of Y3, right?
Yeah.
So what's the variance of Y1?
As 20.
20, yes. What's the variance of Y2?
20.
Yep. So this will be 20 as well, right? So
So 2
essentially,
times.
right, this becomes 3 variance of Y. Make sense?
Mm-hmm.
Yeah, but why did I show you this? Okay, why did I show this? What if I have, instead of Y1 plus Y2 plus Y3, the question is modified to X plus 3Y to be greater than 400. If the question is changed to X plus 3Y greater than 400, like what we did just now, we compare this to this. Is X plus 3Y equals to X plus Y1 plus Y2 plus Y3?
No.
No, they are not the same. Because 3Y means I'm going to pick one bottle off the Coke shelf and I times 3. You get what I'm trying to say, right?
Yeah.
Yeah, because the variance of 3y is equals to 9 variance y. But in this case, if you compare, this is only 3 variance y, this is 9 variance y. Understand? So there is a difference. So always be careful when manipulating the variance, okay? Always go back to fundamentals and try to manipulate it manually. Okay? Okay. Right now, let's move on. Okay, we have also tried this before, but I think it's been a while since we come to normal distribution. So let's do a recap of this again.
Yeah, I'm writing down the.
Okay.
Okay.
Okay, 1 minute. Give me 1 minute. All right. Okay, example 3.5. Okay, this will be an actual A-level question. Okay?
Yeah.
Okay, so right now, we will have to break down the question. So remember, step one was to define the random variable, right? So over here they say that the length in cm of a rectangular tile is normal variable with mean 19.8 and 0.1. In this one line, we can already define the random variable, okay, which is x is equals to what? The length in cm of a rectangular tile, right? Yo.
Yeah.
Yeah. Then this in cm, right, is extremely important. I need to repeat again. It's extremely important because, right, there are some questions where the setters are a bit sadistic. What they do is they will change all these things to meters, but students did not recognize it. They just use the value as it is. They did not convert to cm.
Okay.
Yeah, so that's something to take note. Okay, so from this first line, we can already know the random variable and also the distribution. So we know x follows the normal distribution with mean 19.8 and, oh dear,
Yeah.
19.8 and standard deviation 0.1 square.
Yeah.
Okay, so we have already done step 1 and step 2. So step 3 is what? Define the
Breath.
the breadth over here, correct? So okay, maybe we don't use x. Okay, maybe let's not use x, yeah, because we have two random variables. We use L instead. Okay, we use L. L equals L follows normal distribution. Then we have to define another one. which is B. B is equals to breadth of the rectangular tile. So B follows normal distribution, 9.8, standard deviation 0.1 as well. Okay? So with that said, after we define distribution, next up, define problem, right? So what's the problem? Oh, right over here. The sum of the lengths of the 5 randomly chosen tiles exceed 99.4. Can you write it down, write it out here in mathematical form?
The length. You want me to write down on the screen?
Yes. By right, you can write down on your paper lah. But the thing is, I cannot see it.
No, exceed. Is that okay?
What did they ask for? The probability. They asked for the probability. So what you should have is this.
Okay.
So that is step 3, right? The step 4, because now you know that there is something very complicated here. So our job in step 4 is to redefine the new random variable. Yeah, okay, good enough. So that will be how you should be doing it. Okay, this is perfect. Okay, show me for B. I just want to know how you denote it. Good enough. So from there, you know what to do as well. Okay. So, oh, there's typo. So find me part C. Give me a while, I'll go and grab some water.
Okay.
Yo. So you're not going to Malaysia anytime soon, right?
Yeah.
I mean, you can't go also. Okay, they ask for the sum of 50 randomly chosen tiles exceeds. Correct. this part here is correct. So expectation of this is also correct. Variance also correct. Yeah, awesome. Okay, so from here on, anything that you do is nothing conceptual already. Okay,
Okay.
it should be a very easy follow through. You need a water break or something.
Uh, yes.
Okay, we come back by 6:32.
Okay.
You can mute your side.
It's okay. There's no one in the room anyway.
Oh, okay.
I'm done.
Oh, okay. Okay, previously we learned about standard normal distribution as well. Remember I told you about this?
Yeah.
0 and 1. Okay. Basically we can change any mean and variance. Okay, we can change any random variable with a totally different mean and variance to 0 and 1. Okay. All means and variances we can change it to 0 and 1 by using this method called standardization. Okay. How do we do it? This is how we do it. Okay. We just need to introduce a new variable called z. Okay. Introducing a new variable called z, and then using x minus mu over sigma. That's how we would. This is our new random variable. Okay, we need to recreate a new random variable of x minus mu over sigma. Is it always this random variable? Yes, it will be. Just by doing this, we will be converting the distribution to become to have a mean of 0 and a variance of 1. Okay, I think let's jump into a question so you can know better. So let's say, for instance, this. Okay, look at this. Let's say this question has normal distribution with mean 7 and variance 35. Okay, so how are we going to change? How are we going to change the mean, this distribution to have mean 0 and variance 1? Okay, so firstly, we just have to let z be equals to x minus 7 over square root 35. Okay, and this will follow a normal distribution of 0, 1. Can?
Yeah.
Yeah. So you must always state this first. This is a very, very important thing to state. Once you state this thing, the distribution will change to 0 and 1. Means when you key into calculator, you're just keying 0 and 1. You're not going to key 7 and 35 anymore. Understand? So let's say if the original question was, okay, probability of x is lesser than let's say for instance 8. Okay, right now I want to change the distribution. So when I change distribution, it will be probability of x minus 7 over square root 35 will be smaller than 8 minus 7 over square root 35.
How do you know that it needs to be 8?
No, this is just a random question. Like let's say if this is just a random example.
Okay.
Okay, so let's say if the question wants you to find probability of x less than 8. So then you want to use standardization. You have to reconvert this x into a new variable, which is exactly the same as this. So when you whatever you do to the left hand side, you must do to the right hand side. So that's why you will get this. From here, you can say that, oh, so it's probability of z to be lesser than 1 over square root 35. Okay. Then from here, you'll be able to utilize the mean and variance as 0 and 1 to find your probability. Get it?